Alright, welcome to day one of parallel and perpendicular lines. Now we're going to start out with a couple of definitions. First, parallel lines. Parallel lines are lines that are in the same plane and never intersect, so they're never going to cross each other, but they're still in the same plane. Skew lines, on the other hand, are lines that are not coplanar and do not intersect. The biggest way to be able to recognize skew lines is that they're going to be pointing in different directions. And then parallel planes are planes that never intersect. Let's look at a few examples of what this will look like. So here we have a box with a bunch of lines drawn on it. We want to find a line parallel to CD and containing point A. So this line, it needs to go in the same direction as CD, lie in the same plane, but never intersect CD. Think you got it? The correct answer is line AB. Next, we want to find a line skewed to CD that contains point A. So this line should never intersect with CD, and it's going to be pointing in a different direction. Take a moment to see if you can figure it out. The correct answer is AH. Next, we want a line perpendicular to CD that contains point A. That means that it should meet at a right angle. Any ideas? Good, it's AD. Last, we need a plane that's parallel to EFG and contains point A. So if you have trouble visualizing, EFG is this plane that I'm highlighting right here. So you want one that's parallel to that. That means that those two planes will never cross. That is ABC. Okay, now we've got two postulates that we need to talk about here. The parallel postulate tells us that if there's a line and a point not on that line, then there's exactly one line through the point parallel to the given line. What does this mean? If we look into the picture I've got drawn here, this red line and the red point, if we look at those together, there's only one line that's going to go through this red point, but to be parallel to the red line. And that's the line that I've got marked here in blue. Similarly, the perpendicular postulate tells us that if there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So that means we've only got one line that's going to go through this point and cross the line at a 90-degree angle. Our last definition on this page is a transversal. A transversal is a line that cuts across two other lines. So if you take a look at this picture, our transversal is the blue line. Next, we're going to look at a bunch of different angle pair relationships that are formed by a transversal. The first one we have are corresponding angles. Corresponding angles are basically angles that, if you look at the transversal and the line that's cutting across, they're in the same spot. So both angles 1 and 2 here are above the line that's being cut through and to the left of the transversal. Alternate interior angles will be between the two lines that the transversal is cutting across on opposite sides of the transversal. So interior means they're inside the lines, alternate means they're on opposite sides of the transversal. Alternate exterior means that we're going to be looking on opposite sides of the transversal. Again, we've got that word alternate. And exterior means we're going to be looking outside the two lines that's cutting across. Consecutive interior angles. Consecutive means we're going to be looking on the same side. Interior means we're between the lines. So we've got these two angles on the same side of the transversal, both inside the lines that it's cutting through. Same side exterior. Similar concept, we're on the same side of the transversal, so if you look, both of these are on the left, and we're going to be outside this time. So, I want you to take a moment to see if you can find all of the different pairs of angles that fit these angle pair relationships. I want you to pause the video now and try to do all 5 of these. Okay. So the pairs of corresponding angles, again, these are the ones that are in the same position relative to the transversal. We've got 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Our alternate interior angles, these we want on opposite sides of the transversal between the two lines. We have 2 and 7 and 4 and 5. For alternate exterior, we should have 1 and 8 and 3 and 6. So remember, alternate exterior, we're outside the two lines on opposite sides of the transversal. Consecutive interior, we want to be on the same side of the transversal between the two lines. We have 4 and 7 and 2 and 5. For same side exterior, we want to be on the same side and on the exterior of the two lines. That means outside of the lines. In this case, we've got 1 and 6 and 3 and 8. For example 3, now we have pairs of numbered angles and we want to classify them using these terms. Take a moment to see if you can figure these out on your own. For A, you should have that these are corresponding angles. For B, we have alternate exterior, and C is alternate interior. Okay. The last bit that we have to cover here should be review from Algebra 1. Hopefully you remember that. Slope is the rate of change for a line. So there are a lot of different ways we can represent this. Rise over run is something that you'll see when you're dealing with graphs. Change in y over change in x is another one. And then, of course, the lovely slope formula, y2 minus y1 over x2 minus x1. Down here we have just some visuals for what the slopes might look like. A negative slope is going to be decreasing as you go from left to right. Positive slope is increasing left to right. A zero slope is going to give you a perfectly horizontal line. An undefined slope or no slope is going to be a vertical line. So, using the slope formula above, I want you to try to find the slopes for each of these lines. Take a moment to do that on your own. Okay, for A, we subtract our y's. 8 minus 6 gives us 2. Subtract the x values. 3 minus 4 gives us negative 1. And then this fraction reduces to a slope of negative 2. For B, where'd it go? There we go. Sorry about that. For B, we've got negative 1 minus 9 over 2 minus 2. This gives us negative 10 divided by 0, and if you remember anything from elementary school math, dividing by 0 causes the universe to explode, and we get an undefined slope. C and D your teacher will go over with you in class. Alright, parallel lines we talked about before. Those are lines in the same plane that never intersect. An important thing to notice about their slopes is that they'll always be the same. So if two lines are parallel, they have the same slope. Perpendicular lines, on the other hand, are going to have slopes that are opposite reciprocals. Now, in case you don't remember that phrase, opposite means that they have opposite signs. So if one's positive, the other one's going to be negative. And reciprocal means that if you take them as a fraction and flip them, you'll get the other one. Okay, now for this one, hopefully you're listening and haven't muted the video because I'm not going to be writing the answer down on the screen. For the blue line, A, our slope is rise over run, so we're going to count up 1, 2, 3, 4, and over 1. So our slope for A is 4 over 1. For B, we go up 1, 2, 3, 4, and over 1. That's the same as our slope for A. Interesting. And then for C, we go up 1, 2, 3, 4, 5, and over 1. So, because A and B have the same slope, 4 over 1, those are going to be the two lines that are parallel. Okay. Finally, example 4. We want to look at two lines. We've got points on those lines so we can calculate their slopes, and we want to know, are the lines going to be parallel? Now, here I've written out the calculations for the slopes. You'll notice that one of them is 2 over negative 5, the other one's negative 2 over 5. Hopefully you remember that these two fractions are equivalent. So if we have the same slopes, are the two lines going to be parallel? Yes, they are. Remember, if two lines have the same slope, that means they're parallel. I want you to try example 5 on your own. Have something written on your paper before you come into class. Your teacher will go over the exact answers when you get there. Have a great day.